Hi, everybody. Welcome back. In the last few lectures, the natural numbers and maybe the rational numbers a few times have kind of been the stars of the show. Right? We've talked about things like induction and cardinality and countability, where it was all about how big is a set and can we take post-it notes with all the natural numbers listed on them, line them up, and stick them on the items we have. So in this lecture, the real numbers come front and center. So, first and foremost, this is kind of an obvious thing that everybody's seen before in algebra, but it's worth pointing out because we're going to use this idea so often that it's worth maybe you making a note of and going back later, making sure that you recognize it when you see it. So, if we have two real numbers, x and y, and say x is smaller than y, what would happen if I took the reciprocals of x and y? In other words, I looked at 1 over x and 1 over y. Well, okay, so if you just with an example, it's kind of obvious how this has to work. So 2 is less than 3, right? But if I do the reciprocals and look at a half and a third, well, the half is bigger than the third, right? So when you take the reciprocals of numbers, the order switches. Okay? Now, this is, of course, assuming the way I've written this, that neither x nor y are 0, because I can't, say 1 divided by x if x is actually 0. Another interesting thing that happens with ordering is if you have a positive number and you multiply through the inequality by a positive number, the inequality doesn't change. So if x is less than y, and we have a positive number z that we multiply through, xz will still be less than yz. But if x were negative and multiply through by the z, then xz will be bigger than yz. And again, you can easily see this, right? If 2 is less than 3, then what happens if I multiply by, say, negative 1? Well, negative 2 is actually bigger than negative 3 because if you imagine this, explaining this to elementary children about what negative numbers are, sort of like, if I owe somebody 3 Pokemon cards, then that's worse than if I only owe them 2 Pokemon cards, or whatever analogy you come up with to try to explain this to first graders. So, okay, we've seen absolute values before. In fact, we introduced them when we talked about proof by cases, because this is an excellent example of a piecewise defined function where the absolute value of x is just x if x is bigger than or equal to 0, but it's minus x if x is negative. In other words, we change the side if x is negative, which of course means that the output of this function will always be bigger than or equal to 0. So this function's range is just 0, including 0, because the absolute value of 0 is 0, all the way up to positive infinity. Right? So again, we've seen this when we did proof by cases, because we'd often break things down into cases. But I want to study absolute values a little bit more closely, just because we're going to use it so much that getting used to the way absolute values work now will help it. Well, okay, here's the thing. We're going to get into some really hard stuff very soon. And the really hard stuff is hard enough as it is. Trying to figure out the hard stuff without trying to strain to figure out how the absolute values in the statements of the theorems we're going to have works, is just too much. So, more about absolute values. That's the whole point of what we want to do now. If we have two numbers, x and y, and I put absolute values around them, then most people just do this, but you may not have realized that yes, this really is a rule, and yes, this really does work. If you put absolute values around x, y, then you could split the absolute values and do the absolute values around each one separately. Okay, how would you prove this? I mean, I'm not going to go through and do the proof because it's not terribly difficult. But you could just do this with cases, right? So if x and y were both positive, what would happen? If x and y were both negative, what would happen? If one was positive and one was negative, what would happen? And you see that either way, the absolute values are going to start making everything positive once you take the absolute value. So it all comes out to be the same. Much more important than just that is the triangle inequality. So this says that whenever you have two numbers x and y, if you look at the absolute value of x plus y, that's less than or equal to the absolute value of x by itself plus the absolute value of y by itself. So why do you call this the triangle inequality? Well, if you write out geometrically what this means, this is sort of saying that when you have a triangle, no side can be longer than the sum of the other two. That's one way of saying this. The way we'll see this maybe more often is not with x plus y on the left hand side, but with x minus y on the left hand side. And that's exactly the same because if I were to take the absolute value of x minus y, okay, and apply the triangle inequality above to this, then I would get the absolute value of x plus the absolute value of negative y. But the absolute value of negative y is just the same as the absolute value of y from the result we had on the last screen. So this is the incarnation of the triangle inequality that we'll use most often. We'll have the absolute value of something minus something, and then we can immediately turn that into, well, that's less than or equal to the first something plus the absolute value of the second something. That's super important. I often will refer to analysis as something like it's the theory of calculus. Right? I've said that several times through the class, but the truth is maybe a better way of saying what analysis really is, especially once we start talking about limits. We get a little bit further into this. Is analysis is really the study of the triangle inequality, because we use this so much. There's also a reverse triangle inequality. So this is not as useful as the triangle inequality that we've seen on the previous slide. But when you need it, you need it. So let me explain how this one works. If you have two real numbers x and y, and you take their absolute values by themselves, then you look at the difference between those absolute values and take the absolute value of that. Now that sounds all really weird, but what is that really? I mean, think about what would happen if you had two numbers like 3 and 5. Okay, then the difference between 3 and 5, when you take the absolute values and whether you don't, doesn't matter much. And so you actually get equality with the absolute value of 3 minus 5 is equal to the absolute value of 3 minus 5 if both x and y are positive. What could happen though is suppose you had 3 and negative 5. Okay, then when you take the absolute value of both of those and find the absolute value between the two, instead of checking 3 and negative 5, when you take the absolute values, you'd be back to 3 and plus 5. You get 2 on the left hand side of the inequality, and you get 8 on the right hand side of the inequality. So that's just some idea of why this works. It doesn't show up very often, but when it does, we really need it. So this is something to add to the list of things we just have to know. Okay, well, what is this absolute value thing really, though? I mean, we've written down its definition, with two cases about taking things and making them positive or something like that, or taking x and leaving it alone if it's already positive and changing its sign if it's negative. But what is it really? Well, maybe the right way to think about it for our purposes is that the absolute value of x is really the distance from x to 0. So if you look at the absolute value of x minus y, then that'll just be the distance between x and y. Okay? So we're going to see absolute values constantly from now on. And the way to read what that says is as a distance. Okay? Let me give you an example. Suppose you have the absolute value of x minus 5 is less than 2. So the way to read that is not to say absolute value, blah, 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 equation, boring stuff, whatever. The right way to think about that is this inequality says that the distance between x and 5 has to be less than 2. Okay? So let's work through and see how this would play out if we tried to use the definition to figure out what x had to be. So if I tried to use the definition of the absolute value, which is fine, right? In fact, this is the way I would teach someone how to do this. I would say, well, there's two possibilities. The x minus 5, that I'm taking the absolute value of, might be positive. Do this with cases. If it is, then the absolute value doesn't change the x minus 5. So x minus 5 will be less than 2, and if you add 5 to both sides, you get x has to be less than 7. On the other hand, the x minus 5 might have been negative. In that case, what the absolute value does, right, according to its definition, is change its sign. So you would get minus x minus 5 should be less than 2. Now you start trying to solve that inequality. Well, if I take the minus sign to the other side of the inequality, that flips the sign around. So you get x minus 5 should be bigger than negative 2. Now you add 5 on both sides and x will be bigger than 3. So This is a standard sort of problem you might see in high school algebra. When I saw this the first time, I was told by my teacher, oh, here's how you do this. You always make this x minus 5 is less than 2, kind of the way it looks. You just ignore the absolute values. But then, because the absolute values are there, you have another thing too. You have to make it x minus 5 is bigger than negative 2. I'm sure most of you have heard the same thing. But nobody ever explained to me why. Right? And of course, now you see exactly why. It comes from the definition of the absolute value. We have two cases. X minus 5 could be positive, in which case the absolute values don't do anything, or x minus 5 could be negative, in which case it changes the sign. But in either case, what's really important here is where does the x live? Well, between 3 and 7, right? And that's because, another way of reading this inequality is that the distance from x to 5 has to be less than 2. In other words, let's draw a picture here. So here's 5, and I say, where could my x live? It's got to be somewhere on this number line. Where could it live? Well, the distance from 5 has to be less than 2. So it can't be any more than 2 away from 5. That means I could go 2 in this direction and all the way up to the 7, or I could go 2 in that direction all the way down to the 3. That's it. X has to live somewhere between 3 and 7. And because that's strictly less than, I can't count the 3 or the 7. It's open interval 3 to open interval 7. Okay? Um, Closely related to this is a really important fact that we will start to see more and more later as we start playing with what absolute values tell us in terms of distances. And very soon, our friend the epsilon will be showing up everywhere. And we'll have statements like this, like the absolute value of x is less than or equal to epsilon. So what does that really mean? Well, the absolute value of x is the distance from x to 0, right? So how big could x be? Well, it has to be within epsilon of 0. So that means, the second line there, it could be as big as epsilon or as small as minus epsilon, but it's got to be within epsilon of 0. It's got to lie in an interval from negative epsilon to plus epsilon. Okay? We try this with two other numbers. Let's try this with x and y. If I say the absolute value of x minus y should be less than or equal to epsilon, what does that mean? Well, that means they have to be within epsilon of each other. Or another way to say that is, if you think about this from y's perspective, right, where can y live? Well, y can't be any more than epsilon away from x. So that means that if you think about y, it could be as small as y minus, it could be as small as x minus epsilon, or as big as x plus epsilon, but it can't wander very far away from the x. It has to be in this interval between x minus epsilon and x plus epsilon. Okay, so this fact may seem really weird. It's like, what are you doing? Why are we writing things like this now? That's an excellent point, and this doesn't like it's going to be terribly useful or interesting, except very, very soon we're going to be using epsilons and inequalities like this all over the place. And if you don't have this idea in your head, that you understand when you see an absolute value of x minus y less than epsilon, what that's really telling you is x and y have to be within epsilon of each other. It's really telling you something about the distance between x and y, right? Then the important, complicated analysis stuff we're going to get to very soon, the calculusy stuff when we do limits, that'll all be completely bewildering because you see the absolute values and what does that mean, and I don't understand. The point is, absolute values are really telling us about distance.